Hello dear students, welcome to Pen and Paper Chemistry on YouTube. Our topic is potassium dichromate, preparation, properties and of course uses. Uses, you know plenty. You have been using potassium dichromate in the laboratory, in your organic analysis, inorganic analysis where you do the qualitative analysis, quantitative analysis. Don't worry, these are nothing alien to you. You have been using in organic compounds, you've been using it to convert alcohols to aldehydes, aldehydes to acids. Qualitative analysis means where you analyze what type of ion is present. There are gases which you have identified using acidified potassium dichromate. Which one is it? Very good. Sulfur dioxide. You've also done, can you recall the chromyl chloride test? We shall be discussing it later in the lesson. Chromyl chloride test. Yes, you use it to test the chlorine gas and the presence of chloride ions in any salt. Quantitative analysis. Do you remember volumetric analysis where you would have used potassium dichromate? Yes. Now, this is a compilation of the analytical uses of potassium dichromate. Can you list some other industrial uses and large-scale uses of potassium dichromate? Yes. The color is orange-red. They are orange-red crystals, but the problem is that they are not easily soluble in cold water. They are sparingly soluble, but they dissolve readily when that water is heated. Their melting point is 669 Kelvin. Something interesting about potassium dichromate or the dichromate ions is, so basically we've got the dichromate ions and the potassium ions are surrounding it just like in an ionically bonded compound. Here if you see the structure of dichromate, so 2 chromium, there is 3 oxygen here and 1 oxygen is acting as a bridge. If you break this structure, it will be easier for you to understand how we have the chromate ion, Cr. This is, we have the tetrahedral structure. You remember we've been talking about tetrahedral in our earlier topics as well. So we've got these 4 oxygen atoms present like this. Right, 109 degrees, 28 minutes, correct? So CrO4, when it has to form Cr2O7, 1 oxygen starts acting as a bridge in between the 2 chromium atoms, giving a bond angle of 126 degrees, 180 picometer bond length, 163 picometer is the bond length. Why does it exist in these 2 forms? Or when does it exist in many of these forms depends upon the medium. In an acidic medium, the chromate ions get converted into dichromate ions. Whereas in an alkaline medium, the dichromate ions will convert to chromate ions. How will you identify which one is which? Chromate ions, yellow color. Dichromate ions, orange, red. Right? You must be wondering why I am doing it in different colors. Colors embed better in the mind, right? So when you are writing these notes and especially when you are drawing structures, if you have felt tip pens or sketch pens or colored pencils handy, please draw these structures with colored pens. So in the examinations, when you will close your eyes, it is the colors which you will remember and it will be easy for you to recall that structure. Try it for one topic and you will see the difference, right? Because after this, I am going to give you the preparation and the properties flow chart as well. This particular transition we are going to use in preparation as well, where we will convert the chromate to dichromate. So should we go ahead and understand the preparation of potassium dichromate, how it is prepared. Don't forget the pen and paper, because without that inorganic chemistry has got nothing. Unless you write the equations in your own hand, it's pointless. So go, get a pen and paper while I rub the board and get it ready for preparation. Let us now start with the preparation of potassium dichromate, and there are 3 steps in this. Chromite ore converted to sodium chromate, sodium chromate then converted to sodium dichromate, and finally sodium dichromate to potassium dichromate. So let's start one by one. I hope you have your pen and paper in hand. I cannot come to check you, but please be honest with yourself. Make sure that you write the equations in order to have full benefit of this lesson. Chromite ore, that is FeCr2O4, is fused with excess of sodium carbonate or excess of potassium carbonate in the presence of excess of air. Fusion means you are heating it. It gets converted to Na2CrO4, that is sodium chromate, Fe2O3 and carbon dioxide. Now this is extracted using water. Fe2O3 is insoluble, so sodium chromate remains in the solution. Now this solution is then treated with concentrated sulfuric acid to convert the chromate to dichromate, Na2Cr2O7. Mind you, we are talking about concentrated H2SO4 and not dilute. Here again, if you see, there is a difference in their solubility. Sodium dichromate is more soluble in water as compared to sodium sulfate. So when we carry out the process of fractional crystallization, the rule of fractional crystallization is the substance which is less soluble will precipitate out first. So what will precipitate out over here? Very good. Sodium sulfate. What will remain in the solution is sodium dichromate. Now last step is to replace this sodium by potassium. So I treat it with potassium chloride. We cool the solution. Again, we will use the concept of greater solubility of one compared to the other. Sodium chloride is more soluble, so it remains in the solution. Potassium dichromate on the other hand, compared to sodium chloride, is less soluble, so orange crystals of potassium dichromate will settle down as crystals at the process. Have you written them down? Is this complete? There is something missing in these equations. Can you spot the missing angle? Yes, it is the balancing. Inorganic equations, inorganic chemistry is incomplete without balanced equations. So, your task is to balance these equations. Pause the video, balance them. If you balance the equations, please tally your answers. I have written the balancing numbers, the coefficients in green so that it's easily readable. And if you've got all the balancing right, please give yourself a big smiley because half of your topic is already done. If you want to gain confidence, make sure that you write these 3 equations once again. And secondly, please don't try to memorize the balancing. Balancing of chemical equations is very easy. If you are not confident about the process, there is a separate video on the channel to explain to you how to balance a chemical equation. But request, don't memorize. The whole fun and the whole charm of learning chemistry goes away when you start memorizing, right? So we now go on to the properties of potassium dichromate. Although few properties we've already discussed. So let's start with the properties of potassium dichromate. Now what I've done over here is I have made it as a flow chart. And if you noticed, I have used 2 different colors alternatingly, not just for easy viewing, but at the same time I'm going to give you quick tips over here. Here we have the compound and these are the various reactions being shown by this compound. First is on heating, it gets converted into potassium chromate, and chromic anhydride is one of the products, plus oxygen. So using this flow chart, you can write equations yourself as well as balance them. How you're going to do it? Let me first explain the flow chart and then we go ahead. Again, potassium dichromate. In an alkaline medium, it gets converted into potassium chromate. We've already discussed this. Whereas in an acidic medium, potassium chromate gets converted into potassium dichromate. This will help you to understand the second step of our preparation, right? Where we converted sodium chromate to sodium dichromate. Third, on addition of HCl, it releases chlorine gas. So what is it doing is, it is oxidizing HCl to chlorine. See over here? That means it's a very good oxidizing agent, is it? So we'll check it out later. Cold dilute H2SO4, here dilute H2SO4. The dilute H2SO4 is behaving more as an acid. So we have the salt over here, CrO3 and water. Hot concentrated H2SO4 helps in the release of oxygen gas. Potassium sulfate, chromium sulfate, water and oxygen. You treat potassium dichromate with any chloride salt. For example, I've taken NaCl over here. In the presence of concentrated H2SO4, gives you potassium hydrogen sulfate, sodium hydrogen sulfate, chromyl chloride and water. Now, yes, chromyl chloride, right? Does it remind you of something? The test that you do in the laboratory for chloride ion. So, if you have to confirm any chloride ion, what do? You take the salt, add concentrated H2SO4 and potassium dichromate. If you get orange-red fumes of chromyl chloride, that means it confirms that the salt has chloride ions. Going on next to oxidizing nature. Potassium dichromate is a very good oxidizing agent in neutral and acidic medium. So it shows oxidizing behavior in neutral as well as acidic medium. What are the various types of oxidation reactions shown by it? Ferrous to ferric, stannous to stannic, HCl to chlorine, SO2 to H2SO4, H2S to sulfur, Ki to iodine and oxalate ions to carbon dioxide. I did not have ample space, that is why I put an asterisk. Now this particular flow chart you can again use an old newspaper or any A4 size sheet and draw the flow chart on it. This will help you to remember as well as revise this topic in just a matter of 5 minutes. Rest, I will teach you how to use this. So first of all, starting the first thing, potassium dichromate on heating gets converted into potassium chromate. So let's start writing the equations for this. We can write if you have the flow chart in front of you, so you have K2Cr2O7 on heating gets converted to K2CrO4 plus Cr2O3 plus oxygen. Have you written this equation? Have you balanced it as well? Please balance it. Let's write the second equation from this. K2Cr2O7 in the presence of an alkali gets converted into K2CrO4 plus water. In the presence of an acid, the reverse reaction. Again, you can balance it. Third reaction, K2Cr2O7 plus HCl, simple, gives us KCl plus CrCl3 plus chlorine plus water. I will teach you how to write this equation in fractional method also, in stepwise manner as well. Fourth, K2Cr2O7 plus cold dilute H2SO4. You have the products here. So what I will do is, I will simply write it as plus H2SO4 in bracket, please don't forget to mention cold and dilute, and we have the products here. Going on to the next one, K2Cr2O7 plus hot concentrated H2SO4. So H2SO4 hot and concentrated, simple. Complete the equation, and at every step please don't forget to balance the equation. It is very essential that we balance an inorganic equation, because otherwise it does not obey the law of mass action, and from examination point of view also you lose marks. The examiner will not give you marks if you have not balanced the equation. So make sure that you just spend 15 seconds to balance our equation and get full marks, right? So let's write this equation as well. See, I have the flow chart in front of me, and using the flow chart only I am writing the equations. NaCl plus H2SO4. This is it. And we get KHSO4, NaHSO4, chromium chloride and water. In the chart itself, I have written test for chloride ions, so I can refer to it later on. Right? Okay. Let's go on to the oxidizing nature. Now comes the interesting bit, because this is where I'm going to teach you the partial equation method. So, potassium dichromate behaves as an oxidizing agent in neutral as well as acidic medium. So let's suppose I'm talking about potassium dichromate with H2SO4. Can you see somewhere where potassium dichromate with H2SO4 is releasing oxygen? Very correct. It's concentrated H2SO4, right? So my equation over here becomes K2Cr2O7 plus H2SO4 gives me K2SO4 plus Cr2SO4 whole thrice. All these formulas, no need to memorize. If you know your symbols and valencies, you will be able to write these equations. Plus water plus nascent oxygen. Potassium dichromate is a very good oxidizing agent in acidic medium. So what will happen over here is it is releasing the nascent oxygen. Correct? Now how does this nascent oxygen come in handy? Let's write the second equation. I told you that I'll tell you a trick how to write the equation with HCl. So it oxidizes HCl to chlorine, right? That was one of the reactions that we have written. Or you would want to take something different. Okay, let me take H2S. H2S plus nascent oxygen. What is nascent oxygen? Atomic oxygen which is released during the course of a reaction. Water and sulfur, right? Next step. These are partial equations. Next step for you to do is to balance each one of them. Pause the video, take time out to balance these equations yourself. So you can treat sulfate as a single entity. Just 3 plus 1 gives you 4 sulfates. So maybe you can put 4 over here. Go ahead, pause the video, try it yourself. Seriously telling you, you will start enjoying the topic much more. So now I've got 4. This we had started, and we get 4 times 2 is 8, so 4 times 2, 8. Potassium is balanced, chromium is balanced, sulfate is balanced. What about oxygen? 4 times 4 is 16, 16 plus 7 is 23. Here oxygen is 12 plus 4, 16 plus 4, 20, and we are short of only 3, right? So 3 nascent oxygen over here. Correct? These 3 nascent oxygen are to be used in the second equation, but before I go on to do that, let's balance the second equation as well. Hydrogen balanced, oxygen balanced, sulfur balanced. So there are 3 nascent oxygen being released. We multiply the second equation also by 3. Got it? Now, 3 nascent oxygen being released, 3 nascent oxygen being used up. Cancels out. What are you left with now? Just add the two equations. Simple. So I have the final equation K2Cr2O7 plus, is there any H2SO4 in the second equation? No. So plus 4H2SO4 plus how many of H2S? 3 of H2S. Why? Because we have multiplied this whole equation by 3. What do we get in the products? We will have K2SO4 plus Cr2SO4 whole thrice. Sorry, SO4 whole thrice. And how many of water? 4 water here, 3 water here. I have 7H2O. And what else? There is 3 of sulfur. Right? So this we have as the final equation for the oxidation of H2S to sulfur. Interesting bit. Now you'll say, oh, this is so time consuming. I better learn the equation. You don't have to learn anything in this. With the help of this simple logic, you can write any oxidation reaction. Now first of all, please check whether the equation that I have got, the final equation, is it balanced or not. If it is not balanced, that means somewhere we've gone wrong in our balancing. Pause the video, check. Go ahead. Potassium balanced, chromium balanced, hydrogen 8 plus 6, 14, hydrogen 14, 3 sulfur, sulfate 3 and 1, 4, sulfate 4. Oxygen is 16 plus 7, 23. Oxygen is 12 plus 4, 16 plus 7, 23. So, the interesting bit over here, when I am talking about any oxidation reaction, what do? Is your first equation remains the same. And by the time you have written your first equation 3 times, it would anyway be stuck in your memory. So if I am talking about converting ferrous salts to ferric salts, right? What will happen? FeCl3 plus H2O. Balance the equation and add them up. Simple. What about tin? Sn2 positive. Instead of Fe, you've got Sn over here. Right? So SnCl4. Don't forget the valency. Balance the equation and add them up. How about, what did we do? Ki. Go ahead. Potassium. Did we do Ki? No. What was it? Yes, oxalate ions. Try writing the equation now. I'm leaving it blank for you. Try it. Confused? Go ahead. H2C2O4, oxalic acid. Oxygen gets converted into carbon dioxide and water. Your first equation is already balanced. Balance the second equation. So we've got 2 hydrogen. We've got 2 carbon over here. I've got only 1 carbon over here. We've got 4 plus 1, 5 oxygen over here. 2 times 2 and 4 and 1, 5 oxygen over here. So 3 nascent oxygen being released, 3 have to be used up. And make sure that you multiply the 3 with all. So basically it is going to be your 3 oxalic acid, 3 nascent oxygen, 6 carbon dioxide and 3 water. Can you write the final equation please? Go ahead. So 3 nascent oxygen will cancel out. Potassium dichromate, yes. 4H2SO4, yes. Instead of 3H2S, what do we get? 3H2C2O4. Correct? Your oxalic acid is COOH. This is how you know it, right? H2C2O4. K2SO4, yes. Chromium sulfate, yes. How many of water? 3 plus 4, 7 water. And what else do we get? We get carbon dioxide instead of sulfur. So plus 2 CO2, is that right? No, it's not right. Why? because 3 times 2 is 6. So that is what I was mentioning, that you have to multiply the 3 with all the compounds that are shown over here. Doesn't this become very easy? Yes? That's very, very interesting to see the smile on your face and the, that feeling of victory. The only thing to be remembered over here is all these oxidation reactions. Now, your first reaction is when you are talking about an acidic medium. What if the medium is neutral? So, I'll give you the first equation for when the medium is neutral. Rest all the equations remain the same. I hope you have written down these equations and not just been watching this video. It doesn't serve any purpose at all by just watching the video unless you write the equation yourself. Believe me, even I make mistakes. If I don't write, I'll just go through it. No, chemistry is not at all just about listening and reading. It's about writing. So when you have any reaction of oxidation in a neutral medium, instead of this equation being the first equation, our first equation will be K2Cr2O7 plus water gives you KOH plus CrOH whole rise plus nascent oxygen. Yes, interesting bit again. I have not balanced this equation. Please balance it, right? So we've got 2 potassium, chromium 2, we've got 3 times 2, 6 hydrogen, we've got only 2 hydrogen, we make it 6. Let's see the the oxygen, 7 plus 3, 10, we've got 3 times 2, 6 plus 2, 8 and 9, 10. Then again you can go on to write the equation as is required. H2S plus nascent oxygen gives you water plus sulfur. Add the 2 equations, you will multiply this equation by 2, right? So whatever is the second equation, you instead of multiplying by 3, it has to be multiplied by 2. Now, after this lesson is over, please make sure that just by looking at the flow chart, you try to write the equations yourself. Simple. That's all that you have to do. Write the equations yourself and then you are done with this topic. And be prepared for the next topic, potassium permanganate, which will also bring us technically to the end of the D and F block elements. Rest remains to be seen. Happy studying, stay relaxed, but stay regular.